So myself, as I've been introduced by Dr. Khandelwal. So I have graduated in mechanical engineering in 1990. Then I've done my MBA subsequently. I worked with ABB Turbochargers, a Swiss multinational, with more than 10 years. Then I started Darwin Marine, this company, in the year 2003 from Bombay, India. Then we have now working in several countries worldwide. Okay, so as a Darwin Marine, as a group, we are 19 years old, ISO 9001 company, and we are dealing in service, repairs, spares, and retrofits of exhaust gas turbochargers. And we are having our own setup and service facilities globally in several countries like India, Singapore, UAE, Bangladesh, UK, China, South Korea, South Africa, Netherlands, Indonesia, and Vietnam. And we are associated with major turbocharger manufacturers, Mitsubishi Japan, KBB Germany, and jobs that we carried out are service overhauls, specialized repairs, retrofits, refurbishment of the components, supply of spares related to the turbochargers. Okay. And now let's move on to the next slide. Okay. So what is a turbocharger basically? Turbocharger is a centrifugal compressor driven by exhaust gas turbine wheel. Okay, before I go into detail, I must tell you this. I have been seeing this seminar. We have got a lot of technical inputs, lot of theoretical inputs. So my presentation is more on the practical side because that's where the implication of the remanufacturing of this thing will be used and how we can develop this turbocharger as a product. So turbocharger is used to increase the boost pressure of an engine. So when you use a turbocharger, the boost pressure of an engine increases. So this leads to better fuel economy, lower of temperatures, better life of the components. And how it works, exhaust gas from engine is passed through a nozzle ring, which converts the thermal energy of the exhaust gas to kinetic energy. And so this kinetic energy used to rotate the turbine shaft. The compressor wheel, which is connected at the other end of the turbine shaft, sucks in fresh air and compresses and leads to the engine. Now this process is very interesting because this turbocharger doesn't use any external energy. It uses the exhaust gas, which would have been otherwise wasted to the atmosphere. And we are increasing the efficiency and power, what I can say, the fuel economy of the engine. So this is how it works. The exhaust gas enters here and converts into this kinetic energy, rotates this turbine shaft here. You can see the turbine wheel here, it rotates and it goes out. At the same time, because it is rotating now this here is called the compressor side. It also is rotating because both are on the same rotor. So this sucks in fresh air, compresses the air and gives to the engine. Okay, this is very interesting technology where, as I told you, we are not using any other external resources to run this equipment. It is using the heat energy of the engine, otherwise it should have been wasted. So normally when you use a turbocharger, we get a lot of advantages. So when I can say cleaner exhaust, that means we are giving less NOx and SOx gases to the atmosphere, which is the talk of the day today worldwide. And also economy, fuel economy, you get better power and also energy recovery. What I told you is have been wasted, we are now recovering. And using a turbocharger, you can see, this is an example, clear example. Now this truck is trying to go up without a turbocharger. Now this is going up smoothly with a turbocharged engine. So this is the difference what we can see physically. And it is, we can see a lot of smoke coming out, and here there is no smoke. So where are the turbochargers used normally? So turbochargers are used, many applications. One of the major applications is marine. In a ship, there are got two types of engines, ship main engine and auxiliary engines. So the main engine is used to propel the ship forward, and the auxiliary engines are for the power required for inside the ship. For example, their internal air conditioning, the operation of the equipments, or the cranes and all that. In both the engines, we need turbochargers are mounted. So this is one of the major applications. Then we have got captive power plant. You can see these are the engines. In many industries, they have got diesel engines mounted in their factories, or they are independent power producers, as I can tell, which are selling electricity to the grid. Of course, this kind of independent power plants are not much in India nowadays, but you can find a lot of them in South Africa or maybe in Indonesia, a lot. And but in India, we have in Andaman and Nicobar Islands. So these all engines are fitted with this. These are the turbochargers here, fitted here. So these are the turbochargers. You can see these are the turbochargers. So when this turbocharger fitted, this also engine efficiency is very high, which is giving regular electricity to the customers around there or the industries which are for the production purpose. In railways also, the turbocharger is used in the diesel engines. So these kind of engines which are mainly for the traction or shunting, also we use the turbochargers. And nowadays, in fact, all the automobiles are having turbocharged engines. So this is also, it has gone to that scale now. Off-road, like all heavy equipments, as well as the automobile industries, everybody is having now turbocharged engines. So these are the practical applications of the turbochargers. Now, this is the main aspect which I was about to tell you all. So how we do the maintenance and service of the turbochargers. So turbocharger service comes in routine service. When I say routine service, that means at a certain hours of operation, for example, 8,000 hours of operation or 15,000 hours of operations, or as specified by the manufacturers, the service has to be done. So this is called routine service. Breakdown service, if there is any emergency breakdown, then these are the breakdown service we have to do. But any case, in case of breakdown service, the situation becomes very costly for the customer. The sometimes ship is mid-sea or something very difficult to reach there. So they spend thousands and thousands of dollars only maybe to send one technician to the vessel. So sometimes this becomes really nightmare situation. And routine services, normally preventive maintenance, we should do in time to avoid this kind of situations. Okay, normally, I showed you earlier, there is a compressor wheel which brings in fresh air from the atmosphere and sucks it and give it to the engine. So the major component is the compressor wheel. You can see the geometry of the compressor wheel. These are all manufactured by CNC machines, 5-axis CNC machines. And these are all aluminum alloys. So first step we do is we do the crack detection test of this kind of aluminum alloys, and also we do the hardness test. You can see here, for example, we have got 128 Brinell hardness, which is allowed because in our applications, if the hardness goes beyond below 120, we have to reject it. And sometimes these edges of the compressor wheels are worn out. You can see these wedges. Now, all the manufacturers, in fact, all the manufacturers of these turbochargers, they recommend it to replace. This is where an opportunity of, repair, reconditioning, or remanufacturing, what you call, is there. This can be a good cost-saving benefit for the customer also. Not only that, suppose there is one problem here and we are not able to get a compressor wheel in time, then the repair doesn't happen in time. Vessel is unnecessarily held up. So this is also one area which needs to be seen. Okay, then rotor. So the turbine rotors, normally we do turbine blades, sometimes it's damaged. We do repairs of the turbine blades. And we do the run-out check of the turbine shaft. If there is any bend or something, then we'll try to repair it. Otherwise, if too much bend, we have to reject it. This is also another scope of opportunity. If there is any unusual bend on the shaft, then how we can straighten it without sacrificing the internal metallurgical properties. Okay, so this is one of the area where also we can start working and give the beneficial things to the customers. Now, this is very important in all our workshops worldwide. We have got Schenck Germany balancing machine where we do the dynamic balancing machine. So I will show you a small video. Let's have it. So as you can see, this is the computer screen showing the place, how much unbalance is there, at what degree. At what degree this unbalance is there. So accordingly, our operator who is doing the balancing, they will correct it and will try to bring this red dot towards center. These red dots will try to come towards center. Because turbochargers are very highly sensitive equipments. They're running at a very, very high RPM. And here you can see we are going into milligrams. These are all grams, 2.54 grams, 1.66 grams. So even such a big rotor having to be corrected in such a minute weight, so that in operations actually there is no problem and there is no vibration and the equipment can run perfectly well. All our workshops are having this kind of balancing machine made by Sheng, Germany. Okay, this is that balancing machine. You can see this the pedestal, and this is the control panel where it is all controlled and it gives the degree where to be correction to be done, and based on that the operators will do the corrections. So these are kept in specialized air-conditioned rooms so that equipments are properly maintained. Now, coming to the real topic where we are now heading to is how we can use our available resources to really bring in technologies to India to develop and really save the cost and also beneficial for both customers and for us and everybody. For example, in the turbine rotors, you can see turbine rotors. In each turbine rotor, this kind of erosions happen regularly. We have seen regularly in almost all the rotors. This is the bearing journal area where there are several pitting marks. These are the piston ring area. They call it piston ring area, which is completely eroded. Now, if we use in this condition, what happens? There is a lot of lube oil which comes out of the turbine shaft this side. That means there is a lot of lube oil liquids from the turbocharger. Now imagine turbocharger running and the exhaust gas temperature at 450 degrees centigrade. Okay. Now if this kind of lube oil leakage happens, it may lead to fire and accidents. So this is a very dangerous situation. We cannot allow the turbocharger to run in this kind of condition. And here, because of pitting marks, this is a bearing journal area. So there is a bush bearing on which the shaft is rotating. So this, because of the pitting marks, there may be a lot of erosion on the bearings, and again the shaft will wobble and there may be accidents. So these are the areas of scope of repairs. Normally we do some kind of repair like laser cladding on this kind of area. Quite expensive now. So this kind of technology we have to develop how we can. Some workshops they go for bushing, additional bushing here. Remove this completely and put additional bushing. So this is an area which needs to really done proper work, and this can be we can improve the life of the components, because this is very, very expensive material. This turbocharger, turbine shafts are very expensive and delivery times are quite high. Another example, you see the same turbine wheel, the vanes, they are damaged. Now when the vanes are damaged, so again, this cannot operate so normally in a field, because it will get a lot of imbalance and vibrations, noise, and leading to the damage. So this all manufacturers, they say replace it, renew it, finish. Because these European manufacturers or maybe Japanese, they also want to earn money. But at the same time, we have to see from our perspective and the customer's perspective, this can be repaired. Like for example, TIG welding or something, because these are all high temperature, nickel, aluminum nickel is what we call that alloys. Okay. Now gas casing, this is another area which we are regularly facing. When the hot gas from the engine enters the turbocharger, the gas casings are used to channelize these hot gases to the turbocharger. So they are subject to very high temperature, thermal stress, corrosions, all kind of stress are developed. So in a period of time, they develop cracks. You can see the cracks here also. You can see the cracks here also. It has gone through from here to here. Here also it has gone through from here to here. So in these cases, what happens? Here also you can see the crack. It has happened like here, up to here. So sometimes what we do, we drill a hole here, for example, and arrest the crack for not going further. But this kind of crack can be repaired by welding needs to be seen, because we tried once or twice, many times in fact, and it is not working. They're all GGG40 materials. Maybe if we improve some materials or change the metallurgy, probably we can do some kind of repairs. This can also lead to faster turnaround of the repair cycles and saving of huge cost for the customers. There is another area where we can do a lot of work also. You can see nozzle rings. They are subject directly to the exhaust gas. The deformation has happened on the vents. Here also you can see the nozzle rings are all damaged here. So in this situation, normally we are replacing the nozzle ring. We are not doing any repairs, we just replace. Get a new nozzle ring, change it. So this kind of nozzle ring vents, if it can be repaired, we can repair it, and probably customers can accept this as a reconditioned nozzle ring with maybe less warranty, but they can have a fuel cost, cost savings, and also easy availability, as I told you earlier. As I told you, this is also the compressor wheels. You can see the two practical cases from two vessels. These are all eroded here. So when this kind of surface erosion at the vents happens, you can see here also eroded, all erosion happens. So when this is eroded, the efficiency of the turbocharger decreases. That means when we are operating at say 67% or maybe 70% efficiency, it goes down, because there's a lot of leakage of air here in this portion. So this has to be built up. Normally, we are replacing it, because no option now at the moment, no established repair procedures for this. So normally we are replacing it. Some workshops they're trying MIG welding, some workshops are just trying some kind of bridging, but we have not seen any success on a large scale level. So probably all the manufacturers or the good reputed workshops, they will just renew it. And these are really very expensive items, these kind of compressor wheels. And again, delivery times are very, very high. Normally, in case of KBB Germany, for example, 4 weeks or maybe 6 weeks. So a vessel will not be waiting for that. So normally vessel goes out with this kind of damaged compressor wheels, like, sacrificing the performance of the engine. So what is the present situation? As you can see, this mostly we renew the parts which are eroded or damaged, and or we do some kind of stopgap repairs to temporarily run the turbochargers till the spares are available. Okay, so this is what is happening now, what we need to do. But there is a lot of, because of this, we have a lot of opportunities, what we can do. Opportunities to develop, you see. We develop special repair and refurbishing technologies to reuse the old spares, extending their lifetime. This is a big opportunity. This is a win-win situation for our own country, our own technology, our own people, and for the customers also. Then study and develop new material and metallurgical compositions for the components to have better resistance to erosion due to hot gas. This is one area which really needs research and can be done, and this can benefit the industry in the practical life. This is also one area which, if possible, we can try to research and do. Install inbuilt monitoring process to provide indication of health of components, to take preventive actions in correct time, avoiding costly breakdowns. This is a nightmare for all ship owners, I tell you. Suddenly ship is going in the middle of the sea, there is a breakdown, and they spend millions and millions of dollars only to get it repaired. Sometimes the cost of spare part may be some $2,000, but they may be spending $30,000, $40,000 only to bring that to the vessel. So this is a good opportunity. If something can be worked out, some kind of a monitoring system can come out from the materials on a metallurgical perspective. Now we have got indications like temperatures, air pressures, or maybe engine load parameters, which is giving some indication that something malfunctioning is happening. But directly from the metal or from the body of the component, if something comes out, that can be much better. This is an area which can be developed. So what are the benefits that we are going to do by using this kind of reclamation or remanufacturing? So we can provide technologies which can reduce costs for the end users, leading to huge cost saving. This I have been telling from the beginning, because everybody is now looking at saving costs in operation, whether it's a ship operator or the power plant operator, everybody is looking how to save cost. So this first this is the first and most important. And second important, first availability of components to complete the repairs. This is a practical problem which we are facing because some parts are not available. Even today morning, a customer vessel is down there. They want some kind of a component is damaged. I just checked. The delivery period is 4 weeks. So they are saying what to do, sir. Kindly help us. So we're trying to bring that component to our workshop, try to see how can do a stopgap repair. So this is really one major area which will help the customers. Then we have more customer. See, options now will be available with customers whether they will use new or remanufactured parts. When I say remanufactured parts, then that means customers will also be given warranty. May not be like a new one, but okay. But at least they know that is a reman parts and they can use it for certain time till they have new parts or something like that. Then improvement of products, metallurgical properties leading to increase in lifetime and reducing TBO, time between overall. This is also one very, very important area if we can develop. Now, for example, if the scheduled maintenance is 8,000 hours. Now, because of improvement of our metallurgical properties, the lifespan can improve by another 2,000 hours, for example, or maybe another 3,000 hours. Then the service and maintenance can be done at 12,000 hours, for example. In that case, that is also saving for the customer and also less headache for them. Then it is a win-win situation for everybody. So these are the benefits. Then what strategies we should do to actually really, from my perspective, which I have been working in this industry for so long years now, and almost 30 years now. So technological cooperation between the actual working industry like us and research organization institutes to foster the developments and testing the outcome in real working conditions. Now, this is one area which is very, very important. In fact, I had been to NIMT Ranchi recently because of this, and as Professor Chattopadhyay just told, we are about to sign an MOU with NIMT to work more and more on this to really have more and more practical solutions for this. Now, we have to develop some special technologies, even though it is already in place, we need to be in a little effective commercial way. Like, for example, laser cladding is now very, very expensive. HBOF metal spraying, there's some of it available, but we can have something similar technologies, maybe at a commercial level where it can be cheaper or maybe more cost effective. I will put that word effectively. This can be used. Laser cladding, HBOF metal spraying, aluminum alloy specialized welding for compressor wheels, and development of improved alloys for components manufacturing. So these are some of the areas which we thought we can really work on for the strategies. We can have more and more as we work together with an academic institutes or research institutes using our practical experiences and knowledge. So this is one example of laser cladding being done in one of the facilities in Singapore. So they use this laser powder technology on repairing the bearing journal area of the shaft. But this laser equipment at the moment is very, very expensive. And these workshops who are doing laser cladding, they are also charging us a lot, because they know the cost of turbine shaft, what it is, they know in the market. So they charge a lot. So this is one area. And this is, I can see HBO metal spray, high velocity oxygen spray. So this HBO spray also we are doing in one of the workshops in UAE, Dubai, for example. And this also nowadays they are being used, but this is only in the case of bearing journal areas where there is a fusion involved. In a normal, in a cold repair process, this is not recommended. But anyway, so what I want to say, there are some at least some work is being going on, even though costs are very, very high. So thank you for listening to this. So now I leave it to the question answer session. Kindly, any questions, please.
Okay. Thank you, sir. Come, sir.
Dr. Patnaik, I mean, we rarely have a lecture in our academic kind of workshop like this. I mean, really I am interacting with people for quite a good time regarding the challenges, barriers, and opportunities of remanufacturing.
Yes, sir.
Often, as you know, unlike China, Singapore, UK, this particular acquaintance of this technology is not yet popular in our country.
Exactly.
And even for organizing this particular workshop, I had to, spend a lot of time to make people understand that
Correct.
this is very important area.
Correct.
But kind of lecture and kind of content that you have presented, I believe that shows the opportunity and particularly demand of this technology.
Yes, sir.
So thank you very much. And
Thank you.
certainly we are looking forward to not only MOU, that is just a formality, but certainly to establish a proper workshop to work in this area and to move ahead from repair to remanufacturing.
Thank you.
Thank
Yes,
you
sir.
very much,
Yes,
Mr.
sir.
Patnaik. We are
Thank you.
really grateful.
Thank you, sir. Thank you, sir.
Thank you, sir. So, this time to now a question answer session, and I believe there is one question for you, sir. If you can see in a chat section.
Where is that?
Can super? This is again.
Can you read the question, please?
Yeah, I think this is a past thing. The can superplasticity be achieved in additive manufacturing part?
No, it is.
Yeah,
it
it is for previous section.
It is for previous section.
Yeah. And there is one participant who has raised the hand. I'll just see. Allow him to talk. Yeah. Amarkant Tirki. Amarkant Tirki, you have any question?
Amarkant, you have to unmute. Mr. Amarkant, you have to unmute. I think.
Yeah.
He has not unmute, I think. That's
There
why
is
we
one
are
more.
not hearing.
Yeah, there is one more.
Santosh.
Yeah,
all are muted.
Yeah, Mr. Santosh.
Sir,
Santosh Kumar.
Yeah.
You can ask again.
very nice presentation by Patnaik Sahab. And sir, I have a simple question.
Yeah,
See, mostly this metal spraying has been old practices.
correct.
And but as the 3D printing technology has come, and DED especially, so DED is one set, and then the metal spray is another set, and third is cladding, the
Okay.
metal cladding
Correct.
that you are talked about with laser. So laser cladding. So cost wise, for an example, you have a turbine blades and all those bigger blades. So cost wise, which one is more suitable for a technical person?
Mr. Santosh has answered this question. The technologies which have developed over the years, we have seen, where, for example, initially it started with some kind of a chrome plating, then it moved on to first went to eutectic repairs. Then it moved on to HBOF repairs. Now latest is laser cladding. Now the technology as it moves ahead, it moves from fusion to fission.
Okay.
So when I'm saying chrome plating is a fusion technology. There is no metal to metal bonding there. So if there is a little impact, there is again erosion, then it goes off. So it is really cheaper but not effective. So that's why people stop that, or either not using or using it where there is no impact. But in turbochargers, definitely chrome plating is not recommended. So we moved to eutectic. When I was working in ABB as a service head, we had established eutectic method. So eutectic is also a fusion method, but again we are hitting the shaft to high temperature, which also has a negative impact of affecting the metallurgy of the shaft, because these are all drop force steel. Suppose I disturb the bonding of that internal grain structure, then there may be a chance of failure of the shaft. So then we moved on to HBOF. HVOP is good. HVOP is not bad. Again, but there is localized heating, too much localized heating. Okay. Then third one now is in practice is laser cladding. But as we
Yeah.
move ahead, the costs are also going up. Laser cladding as of now costs are very high. So people still are moving on to with HBOF or laser cladding. But as a turbocharger repair specialist globally, we prefer laser cladding because we know that component life is not disturbed or there is no disturbance of the metallurgical structure. But
Yeah.
only thing is that I have been discussing with many metallurgical, I mean to say, this laser cutting specialists, including the person from Germany who had really pioneered and invented this technology. He is also a good friend of mine. So we are trying to see how we can really make it in a commercially viable option. I tell you, for example, in a country like UAE, as I talk to, I'm sitting in my Dubai office. In a country like UAE also, it is not popular. In Singapore, it is, but costs are very high. In many countries, in India, we don't have laser cladding. You know that. We only do repairs by HBOI or
Yeah.
maybe sometimes plasma spray. This is very old technology. I'm talking about 20 years old technology, plasma spray. We're still doing that. So we have a huge opportunity for this kind of technology to be brought into India. As an
Yeah.
Indian, I would love to do that, I tell you.
Yes. Thank you. Thank you so much.
Yeah, welcome. Any question else? You have to unmute Dr. Kandalwal.
Sorry, sir. Sorry. So yeah. So if any other questions, participant can actually post it in question answer section or chat section, or raise your hand. Yeah. So there is one question, sir. You can. It is there. So remanufacturing turbocharger is one that has been completely manufactured to the standard of an original new turbocharger. Am I
Yeah,
right?
that's right. Yeah, that's right. Correct. Absolutely. We maintain all the dimensions, everything as per the new turbocharger. Absolutely correct. Absolutely.
Yeah. So I think this is the question, sir. So
Okay.
there's one more question. Acha, I don't know. It is deleted. Yeah. So yeah. So with this, sir, we can end this session. So
Thank you.
sir, so I would like to take this opportunity to present a vote of thanks to you, sir. So thank you very much, sir, for such an enlightening presentation. You have covered a lot of application. I would say, I know industrial challenges, how the industry face challenges in this field, and it is a real problem generally, so that people have got a lot of idea about that. And thank you for sparing time for sharing this wonderful
You're welcome.
presentation to all your participants.
You're
So now, I would with this actually I would like to call the end of this session. But before that, I would like to extend our sincere thanks to Honorable Director Sir, Professor P.P. Chattopadhyay, for his vision and commitment, for this work, and to and also to arrange such a wonderful sessions with great speakers which is there. So in this sessions we had 4 speakers, and I would like to thanks all of them once again for this delivering their lecture on this session on remanufacturing technology. And now before ending, I have an announcement. The next session, which is on remanufacturing and industry 4.2, will start at 3 p.m. All the participants, you can join at 3 p.m. Unfortunately, one of the lecture in that is from Mr. Manas Ranjan Panda, the director STPI Bhubaneswar. So he's a bit feeling under the weather, so he'll not be able to join today. So we have actually, there is some change in the schedule. So we have actually preponed Dr. Naga Hanumaya's lecture. So his lecture will start at 3:45 instead of 3:30. And Dr. Yang Wang's lecture will start at 3 p.m. So I request all the participants to join. Sir, if you have time, you also please join, sir. So
Yeah.
once again, thank you, sir,
You're welcome.
for joining and delivering the lecture today.
Thank you very much. Thank you. Thank you.
So with this, I will end this today's lecture. Okay.
Thank you.
Goodbye.
Good night.